Hi, good afternoon, everyone. In the last class, we had gone ahead and we had talked about limits. Today, I want to go ahead and I want to talk about another important aspect, which is continuity, right? Limit and continuity are very much related to each other. What is continuous function? A continuous function, by layman's language, is such that you draw a curve where you don't have to take off your pen. So, if I have a pen with me and I start drawing this, whatever I draw, I should not be picking up my pen. If I pick it and then I have to redraw it, it means that there is a point of discontinuity. So in a layman's language, continuity simply goes ahead and it means that there should be no break, right? You should not be taking off your pen, right? You should be able to go ahead and do a continuous graph, right? There should not be a point of a break here. Now, when we talk about continuity, so when we were talking about limits, in limits, I was always going ahead and I was always talking about the journey. And I always told you that the destination doesn't matter. Destination doesn't matter, right? So we were going ahead and we were saying that we are related in understanding the journey. We are not related, we are not interested in understanding what happens to the destination at the point. It does not matter. So we were just interested in understanding what happens to right hand limit, what happens to left hand limit. That means we approach a number by taking numbers lesser than it. We approach towards a number by taking numbers a little more than it. And we see how my function reacts. And if these two were equal to each other, we said that this is where limit exists. We were not concerned with the value of the function at a. We were not equating, we were not finding the value of the function at a, right? And whenever you need to understand this concept, you can go back to the example that we did. So in the example that we did, where I had drawn something like this, my function was x square minus 1 upon x minus 1. We said that the function does not exist at x equal to 1, right? So, but we said that when we try to approach 1, the value of the function approaches 2. We are not concerned with what happens at 1. That was not my concern as far as limits were concerned. But now when we talk about continuity, then I am very much concerned with what happens at 1. Am I able to define the function at that point or not? I am concerned with that also, right? So when we talk about continuity, we need to define the function at that point also, right? And now for the definition of continuity, what exactly do I require? Well, I require that, I'm going to write it somewhere here. So I require that, yes, the left hand limit should exist. Yes, the right hand limit should exist. Yes, they should be equal to each other. This much part is the existence of limit. But they should also be equal to the value of the function at that point, right? So I want that at x equal to 1, my function should give me the value 2. If that happens, only then my function will be called as a continuous function. If this does not happen, this part doesn't happen, and only this part happens, then it is not continuous. It is only that the limit is existing, right? So we can say that if the limit of function exists, like here is function के लिए limit is existing at x equal to 1. As you are approaching 1 from both the sides, taking values less than 1, taking values more than 1, the value of the function is approaching 2. दोनों साइड से 2 की तरफ जा रहे थे. एक बार ये आ रहा था 1.999, 1.99999, दूसरी तरफ आ रहा था 2.01, 2.001. So you were going towards 2 from both sides. So we saw that limit of function was existing, but at x equal to 1, it's discontinuous. It's not defined. There is an open circle. Right? So if limit of function exists, function may or may not be continuous. अगर ये लिमिट एग्जिस्ट करता है तो कंटिन्यूटी गारंटीड नहीं है. इट डज नॉट मीन दैट द फंक्शन विल बी कंटिन्यूअस, राइट? बट इफ द फंक्शन is continuous. Continuous means that this entire condition has been satisfied. So now that the function has become continuous, we are sure that the limit definitely exists. And if limit doesn't exist, like we had taken the example of a step function. Step function was the case where limit itself was not existing. कोई limit ही exist नहीं कर रहा था, because the left hand limit and right hand limit value was not equal to each other, right? We had done this example. तो अगर limit ही exist नहीं करती, if limit itself does not exist, then definitely it is not continuous. Then definitely it is not continuous. So these 3 points are important. अगर limit होगी, it just means that left hand limit equal to right hand limit. It does not mean that the value of the function exists. This may or may not exist. So it may or may not be continuous. Other continuous hai, it means that left hand limit equal to right hand limit equal to value of function. It means that the limits are equal, so there is existence of limit. But if limit itself is not existing, if left hand limit and right hand limit are not equal to each other, then definitely we are sure कि function continuous तो नहीं ही हो सकता. The function cannot be continuous, because for continuity, existence of limit is a necessity. That's the minimum thing. It's not sufficient. अगर exist करेगा तो जरूरी नहीं है continuous होगा, but that's the minimum thing which we require, that there should be existence of limit for continuity, right? The left hand limit and the right hand limit must be equal to each other. That is something which we require for sure, right? Okay, now let's take some examples. Suppose my function itself is this. Fx is equal to x plus 1. So when I will approach 1 with taking values less than 1, right? So for example, I start taking values like 0.99, 0.999, 0.999999. So I'm taking values very close to 1 but less than 1. What will happen to the value of the function? I will get 1.99, 1.999, 1.99999. It means I am going closer and closer to 2. Right? So I told you how to find the limit. In this case, there is no denominator, nothing. It's a simple thing. So you can directly plug the value 1 here itself. So you know that it is approaching 2. Right? Similarly, if I go ahead and I find the limit of this function at 1 plus fx, so this will be limit x tends to 1 plus x plus 1. That means again I have to take values close enough to 1, but more than 1, right? So it will be 1.00001, 1.000000001, something like this. Close enough to 1, very, very close to 1. So, if you take x values to be these, right, what will come out to be the value of the function if I plug x here? So I will get this. So I will get value again very close enough to 2. So I can simply plug in 1 here and I will get the answer as 2. Right? When it is a very straightforward function like x plus 1, x plus 2, there is no denominator, nothing. There is no need of anything. We have done method number 1, where you simply plug in the value and you get the answer of the limit. So you see that both ways you are approaching to. And of course, you can go ahead and find the value of function at 1 also. So if I just plug 1 here, I will get 1 plus 1, which means 2. Right? And if I try to plot y is equal to x plus 1, then my function looks like this. Right? So at 1, the value of my function is 2. And as I go towards 1, 0.9, 0.99, 0.999, my value of function is going towards 2. And as I go towards 1 from here, right, 1.01, 1.001, 1.0001, I'm going closer and closer to 1. Again, I was approaching 2. So we have existence of left-hand limit, right-hand limit, and value of function, each equal to each other, which is 2. So we can go ahead and we can say that, yes, it's a continuous function. Now, what some books do to find limit is that when they say 1 minus, when they are finding the left-hand limit, that means they use 1 minus. What they do is they replace this by saying limit. Instead of, because x is going towards 1 minus, so instead of x, they write 1 minus some h, where h is very, 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 very small. But 1 minus h ensures key it is less than 1, right? And then they just do plus 1 and h tends to 0. Why tends to 0? Because h is very, 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 very small. बहुत छोटा है h. जैसे if I would have taken x to be 0.99999, so it is nothing but 1 minus 0.00001, something like this. So this h is very small, 1 minus h. Right? So what some books will do is that this x will be replaced because x is going towards 1 minus. It means it is taking some value lesser than 1. So it becomes 1 minus h and h approaches 0. Right? So you go ahead and you get here limit h tends to 0, 2 minus h. And then you just plug h to be 0. So you get the answer as 2. Similarly, when we need to do 1 plus, it means I need to take a value very close to 1, but more than 1. So this x, so limit x tends to 1 plus fx is limit x tends to 1 plus x plus 1. So this x is replaced with 1 plus h. Very, very close to 1, but more than 1. And then I have limit h tends to 0. Right? And then we go ahead and we solve this and we get 1 plus 0 plus 1. And this also gives me 2. So the right hand limit is also 2 and the left hand limit is also 2. This is another way in which we go ahead and we kind of solve it or we kind of show these kind of questions, right? Now, let's try to look at one more example. So this is example number 2. Now, this example I've already discussed with you. So what happens is that this function is not defined when x is equal to 1, right? So although we proved that this limit of the function exists, but function is not defined at x equal to 1. Therefore, it's a discontinuous function. So it is a discontinuous function here because it's not defined at x equal to 1. Look at the next one. Now, this is interesting. So what they have done is they have said that this function has two aspects to it. The first aspect is x square minus 1 upon x minus 1 when x is not equal to 1. And the second aspect is 2 when x is equal to 1. Right? So this is similar to what happened in the previous question. But now what they have done is they have specifically said that when x is 1, the functional value is 2. So now what we have here is if I try plotting it, if I would have plotted only this much, So from our previous class, we know that we were getting something like this, that at 1, it is 2. This value cannot be achieved. You don't have the function defined at 1, but other places it's defined. But now what they have done is they have given you an additional set of information. And it says that, look, when x will be 1, then the value of the function will be 2. So when x will be 1, the value of the function will be 2. So they have closed this circle now by giving you exactly how the function acts when x is equal to 1. Right? They have defined how the function acts. So now, therefore, what has happened is because this circle gets filled, this becomes a continuous function. Because I know that at x equal to 1, it is taking value 2. So f of 1 is 2. And I know that for this function, the left-hand limit and right-hand limit were coming out to be 2. Right? So all three are equal to each other. Hence, it is a continuous